All right, we are the Jolt customer tracking team, and I'm Kendall. Chris, Devin, and Sam are on, and we'll definitely be talking later on in the presentation. So Jolt primarily is a company that makes software for restaurants, and recently they decided that there was a product out there that they had an idea for that would help them help their restaurants keep track of their customers, especially their repeat customers. So when people come into restaurants, they buy things, preferably. They sit down for a while and then they leave. And one of the things that Jolt was interested in, and companies have been interested in the past, is how often do they come? How often do they come back? How long are they staying for? That kind of data and information can be potentially useful to them. And companies have been trying to collect that for a long time with things like loyalty apps or a couple of other tools, but loyalty apps is the main one that Jolt brought up to us. And instead of a loyalty app, which requires your customers to be a little more proactive, they wanted to build something that would be a little more passive so that even if customers weren't opting in and choosing to engage with the app fully, you could still get the data that the restaurants were looking for. So they also mentioned that pretty much everyone now is carrying a smartphone or some kind of Wi-Fi and Bluetooth enabled device with them at all times. Since most of the people are actually leaving their Wi-Fi and Bluetooth on, because we're lazy, because it's convenient, because we like being able to walk in somewhere we've been before and the Wi-Fi just connects, we leave it on. But as part of that convenience to having that Wi-Fi connect as soon as you get within range, your phone is transmitting all the time and looking for Wi-Fi networks. And so if we can listen for those transmissions, we can figure out, okay, this phone is looking for these it's transmitting. So it has to be close enough to our sensor that you're probably in the restaurant or within a certain range. Bluetooth does the same thing that Wi-Fi does as well. When your Bluetooth's on, it's also transmitting, looking for devices you've connected to in the past, but it has a little shorter range and not as many people have it on all the time.
So this project was cool to us in a couple different ways. We each have our own reasons that we like this project and chose to participate in this project. But for me, this project was practical and interesting, and it solved a real world problem. I really like the idea of hardware and software both on a project. I'd never worked with hardware before, just mostly software stuff. And so it was cool to try to create a physical thing to capture these MAC addresses and Wi-Fi signals, among other things. What about you guys? What do you think was the reason why you chose this project? Kendall?
So for me, a lot of it was I've always been interested in how things work, and I had another class that was talking a little bit about some of the underlying protocols of Wi-Fi. So hearing there was a project that would really let me dig into something that I was learning about in school and really kind of apply what I was learning in school to a real world application is really what drew me in. What do
Devin?
you think? Yeah.
Yeah, I think one of the most parts, one of the biggest parts that drew me to this project is just the idea of working with problems that I haven't worked with before. So, for example, like the Wi-Fi and the MAC addresses, and also, like you said, Sam, with the merging of hardware and software, the fact that we were in charge of the hardware, which is not something that we've been really working with in the past, was really interesting to me.
And Chris, what do you think?
Yeah, so what I liked about it was it's like so your average person can understand the premise and like really get involved in why this project is so interesting. So like if you talk to someone about it, they know what you're saying, you're tracking customers. And so it's nice that you can share the project with other people and they also care about it.
Yeah, for sure.
All right, so to go about this problem, we had two main ways. We could either use a Raspberry Pi or use a router with the OpenWRT software. So with a router, it probably could have been more customizable, but more difficult to scan using Bluetooth. We decided to go with Raspberry Pi 0W model, which has Wi-Fi and Bluetooth built in. It's really small, it's inexpensive, and Jolt was already using this model of the Raspberry Pi for other products. And so it made sense for us to use that for our project. And so by default, the Raspberry Pi 0W doesn't have monitor mode enabled, which is what allows it to scan for those Wi-Fi probes that other devices are sending out. And at first we tried to get that on ourselves manually using the Nexmon drivers, which will give it monitor mode. But that just wasn't working. They weren't installing properly. So we used Kali Linux, flavor of Linux that's used for basically the purpose that we were trying to do. And so it had everything built in onto it, and it uses AirCrack and G to scan for other devices. So it's simple enough to use. You just use one command and you can start scanning. Here's an example of a scan. The top half is the routers. The bottom half is the devices connecting to the routers. And so a lot of this information isn't really needed for what we were doing. So we trimmed it down to just the station MAC address, which is the second column on the bottom, as well as the power column right next to it, which is like a rough distance metric. And then we also collected the times that we saw those devices so we can know how long a device was within the range of the Raspberry Pi, which is basically equivalent to how long someone was in the restaurant.
Okay, so yeah, so how it all fits together, I'll just explain the overall process of this system that we created. So as you saw in the previous slides, well, we have a Raspberry Pi, and that is going to be scanning for Wi-Fi packets and looking in them for MAC addresses. So you can see there's people with smart devices or other devices that are Wi-Fi capable looking for Wi-Fi networks to connect to. The Raspberry Pi, through the scanning, is able to detect those packets and extract the information that we're interested in. The Raspberry Pi also periodically uploads that information to our systems on AWS, and those services will run a few analytics, different analytics on our data, and then finally we can view all that data in a nice format through a website. So one of the services that we're using on AWS is called Athena. We chose this because it really fit the needs of our project, and basically what it is kind of takes the place of a traditional database that might be in other software projects. The difference is that rather than having our data stored in, maybe tables and database files, which might be common with things like relational databases, our data is actually all stored in CSV files. And that's really handy because our Raspberry Pi already generated CSV files, so we didn't have to do any extra configuration there. And then another thing that's nice is that because CSVs are a very standard file type, and sorry, I'm drawing a blank. You can edit this out later, I guess. Anyway, okay, so because Athena is just CSVs and we're not using like an actual database, that allows us to basically scale close to infinitely. If we ever need to make this project bigger, then we won't need to do any more setup with more databases or more powerful servers or anything like that. And then Athena, AWS just charges us per query. So as long as we're keeping our queries efficient, then we can keep the costs down well. Some of the setbacks we experienced while using Athena, it was a new technology for us, so we did kind of have to learn it. But because it's kind of doing kind of a non-intuitive thing, which is putting in kind of like a database querying front end API type thing on top of CSV files. There were some interesting setup things that we had to go through, and that was a little bit challenging. And then second, Athena at this point is not really set up to take the results of other Athena queries as input to new Athena queries. So we had to change a lot of the configurations and look into how we can get the data to match the proper format in order to be able to run new analytics queries on our data.
All right, we have a little working front-end demo that we wanted to show you guys. We have just this front end that we put together to demonstrate some of the back-end work that we were doing. Most of our project was on the back end, but we have this little dashboard that a restaurant owner can come into when they have this product. They can select their store, whichever store they want to view if they own multiple stores, and then view some stats about those stores. So if you want to view daily stats about what happened on each day of the past week or past month, you can go in and click on a day and choose a query and understand a little bit better about what was going on in your store at the time. So it looks like on April 4th, in the Heritage 15 store, this is a dorm room on campus at BYU for demonstration purposes. But it looks like there were a number of people during the day, and then it got more towards the evening. And you can see just a flat daily total, and you can see how long they spent in the store. Average was about 50 minutes. If you want to view stats over the week, you can come in here, click on a Sunday, and see different stats about what days were most popular in your store. Looks like 30th was a big day. But basically you can compare that. You can see your weekly total with a comparison to last week. Repeat visitors. There are 2,000 people that came to your store multiple days in the week, and the average duration of how long people spent there during the week. So this is some basic stats about what your stores were doing, and all this data is just straight compiled from our Pi scans. Just run some analytics on them. And then here's a little leaderboard feature. If you have multiple stores that you want to see how they did in comparison with each other, you can see that all lined up right here. So looks like we didn't have these pies running on the 4th, but on the 4th there were 700 people at Heritage 15 and 400 people at Heritage 16 that day. So you can compare and contrast which stores are doing best. We also have a little campaigns mode that lets you predefine like a campaign that defines a specific date range that you can compare with other data. So this campaign chose a date range and then compared to all of the different data that we have for this specific store, so they can understand a little bit better about their specific date range that they want to look up. Another feature that we talked a lot about is this competitors feature. This feature tracks crossover between different stores. So right now it's tracking crossover between just these stores, but it will track crossover between all other stores of a similar type. So say you have a McDonald's and you want to see how many of my McDonald's customers went to Burger King last week. You can track that here, and it tells you less than 1% of all the people that came to my store also went to Burger King last week. So that it looks like there's 50 people that visited Heritage 15 as well as another store. I think, yeah, it was Heritage 16 was all of them because they're close together. And we talked a lot about this competitors feature because it also can kind of give you a cross-contamination metric. With the coronavirus, we want people to stay inside and not go to different places. We can kind of track cross-contamination between different dorm rooms or different places on campus, seeing the movement of students around campus. That's just another possible use case that we thought of with Jolt. If this coronavirus keeps keeping the restaurants down, and we want to minimize crossover instead of really maximize it. And then this last thing over here is a range configurator. So typically the Raspberry Pi takes a really big range. It's about 7,500 feet. And if your store is smaller, you want to minimize that range, you can cut it down. So in this tab, you can kind of look at a past day, see about how many people were in your store at a specific time, and then understand better what you should use, medium, long, or a short one if you think that more accurately reflects your store. So that's our basic functionality that we have on the front end. Let's go back here. And that is the idea with Jolt Customer Tracker. We wanted to create a product that Jolt could use to give to customers, their restaurants, that they could track their customers a little bit better and understand them better. And we were really excited to work on this project and happy with how it turned out. Thank you.